For today's lesson, our focus standard comes from grade 7, Number Systems, Standard 2. Apply and extend previous understanding of multiplication. Our topic comes from our unit, Multiplying and Dividing Integers, Multiplying with the Chip Model. Our essential question is, how can we use integer chips to model multiplying integers? Please take a moment, pausing the video if you need to copy down the topic and essential question in your header along with today's date, set up your question column in your note column, and resume the video when you're ready to begin. So as we learn about multiplying integers, there is an important thing to note that the sign of the first factor tells us whether to keep or remove the integer chips named in the second factor. So we're going to do some examples today to look at exactly what this means. And since we're using integer chips, I've included a key here. You can use the same key as me, or you can use a positive sign here and a negative here. That doesn't matter to me, but as long as you denote what the color of chips or what type of chip is going to be a positive and what kind of chip is going to be a negative. So for our purposes in this video, yellow will be positive and red will be negative. We're going to look at two sets of problems. Our first set is going to be where the first factor is a positive number. If the first factor is positive, that means we're going to keep that many groups of the integer chips named in the second factor. Let's look at our first example. For number 1, we're looking at 4 times positive 3. So again, this first integer, this first factor is positive, so we're going to keep 4 groups of 3 positives. Now you probably already know this multiplication fact, but we want to make sure we understand how to use our integer chips to model it. So let's take a look. I've started here with 3 positive integer chips. That's how many is going to be in each group, because I can see that from the second integer. And the first number, the first factor, tells me I need 4 groups. So go ahead, here's the first group, draw those in, and then draw in the other 3 groups. So here you can see that I've made 4 groups, 1, 2, 3, 4, each with 3 positive integers. And since the first number is positive, it says we're going to keep those. So altogether we have 3, 6, 9, 12. So 4 times 3 equals 12. All right, let's try our second example. Here in our second example, we have 2 times negative 5. Again, our first integer is positive, so we're going to keep 2 groups of 5 negative integer chips. So what do you think that's going to look like drawn out? If you think you know, go ahead and pause the video here and do that. If you're not quite sure, you can go ahead and see how I'm going to begin to set this up. So it tells me to have 2 groups of negative 5 chips, and I'm going to keep those. So I have one group of 5 chips that are negative, 1, 2, 3, 4, 5, and I need one more group. Go ahead, if you haven't done so already, and draw in your second group of 5 negatives. Alright, so here's our first group of 5 negatives, and our second group. Because this first integer is positive, we're going to keep all of this, and all together we have negative 10. So 2 times negative 5 is negative 10. So in our first 2 examples, we looked at problems where the first factor is positive, and so we kept that many groups of the integer chips named by the second factor. Let's look at 2 more examples. All right. In these examples, we're going to be looking where the first factor is negative. So what that means is we have to remove that many groups of integer chips named in the second factor. What becomes tricky about this is if you're removing integers, you can't do that until you have some integers. So we're going to take a look at what that means. So here we have -3 times 2. So we want to remove 3 groups of 2 integers. But we don't have any, so we have to start with 0 pairs. So here I've made 1 group of 0 pairs, and I need 3 groups of 0 pairs. So let's go ahead and get that done. Alright, so we've set it up where we know we're going to be removing chips, and we're going to be removing 3 groups. So to begin with, we make 3 groups of 0 pairs, and since the second factor is 2, we made 3 groups of 2 0 pairs. And now it's saying remove 3 groups of +2. So that means we're going to cancel out 3 sets of 2 positives. We can just draw a line. We're going to get rid of these 2 positives. There's 1, 2, 3 groups of 2 positives. So if we get rid of those, what is left? Well, we have 1, 2, 4, 6 negatives. That's left. So -3 times 2 equals a -6. Let's try one more. So for our second example, we're looking at -4 times -4. So once again, since our first factor is negative, we need to remove that many groups. We don't have any groups, we have to put 0 pairs on. So we're going to put 4 groups of 4 0 pairs. Here I've made our first group. So in this first group we have 4 0 pairs. We need 3 more groups to be able to complete this problem. Go ahead and draw those in. So here I've made 4 groups of 4 0 pairs, and I'm ready to begin the problem. I'm going to remove, since this is negative, 4 groups of -4. So we're going to cross out 4 groups of -4. So here's 1 group of negatives I can get rid of, 2 groups of -4, 3 groups of -4, 4 groups of -4. And what remains is 4 groups of positives. 4, 8, 12, 16. So -4 times -4 is a positive 16. That's going to conclude our video today on multiplying integers with the chip model. Please make sure that your notes are complete and come ready to do more work like this in class.